All right, so like I was saying, this is Lori. She's a civil engineer. She's in the construction and architecture business. So I'll let her talk about her experiences, her education. If you have any questions, remember, always ask them immediately. All right, go ahead.
Good morning, everybody. So my name is Lori. My degree is actually in engineering studies. It's a Bachelor of Arts, and then I took a lot of civil engineering classes. Basically, I started like you guys in a program for high school students that will it just motivates you to do engineering. I was in a robotics program when I was in high school, and then I went to school. During school, I joined Engineering Without Borders, and that's what led me to be interested in civil engineering. So I will talk a little bit about that, and then what I've done after I graduated. The Engineering Without Borders, basically, we built the water system for a poor community in Honduras. They didn't have water, potable water, so we basically built a system that will enable them to have clean water and be healthy and be more comfortable. I heard someone ask me a question what civil engineering is. Civil engineering is a very broad subject. It's divided into different branches. You have the environmental, geotech, hydrology, construction management, what else? Structures. So, but basically the whole idea is that it deals with projects that will affect the community somehow. It deals with roads, building buildings, things like that. So I'm just going to show you a little bit about what we did on EWB and some things that's going on their website. Let's see. Okay, so basically at the beginning it was my first year in college. So it was my first year in college, so at the beginning I used my Spanish skills. I speak Spanish fluently. Actually, that's my first language. To translate and make surveys because we will actually use grants to fund the project, and we require to write grants and to advertise what we did was important. So we need people to go there and speak to people in the community about how will the project benefit them. And we put them on videos, we write reports about what their conditions are and how we're going to change their lives. So that's basically what I did at the beginning. Then towards the end, I joined more of the design team. So that's us. We usually have community meetings at the beginning with everybody. It's usually from 200 to 300 people that will come in. That's the finished project. There's a tank where the water will go. It's a water-based system. It's a gravity-based system. So we don't have any pumps or any electrical things because they don't have electricity. There's different challenges that you need to deal in engineering projects, any type of engineering, but our case was that they didn't have electricity and it was hard to get materials into the village. So you coordinate that. That's kind of what a construction manager does, which I will talk a little bit about later. So there's us. We usually just go there once a year, no, maybe 2 or 3 times a year for a week or so, and we will supervise what the process was. When we were in school, we will design it. We'll use AutoCAD, we'll write grants. When we go to the village, we'll divide ourselves into different teams. There's a surveying team. They will survey the topographical elevations of the ground. You need to put those elevations on AutoCAD, and then you will determine how big the pipes need to go, how long, and how fast the water is going to travel. We have the environmental team going there. They'll test the sources of water we'll be grabbing water from to test if they're clean, how much we need to purify it, and whatnot. lately they started to do some sound filters, so they have a team special for that. We have the community team. Those will be the people interviewing, and when the project was done, we'll be giving workshops to the people as to how to use the system, because we want them to have a long-lasting system, and we want to teach them how to fix it if something goes wrong, things like that. So that's it for this one. This is a little gift the community gave us. It was a painting that they did. It's very pretty. That was doing the interviews. That's their website, Engineering Without Borders. And these were the teams that I was talking to you about. And this is a very current video that they have. Well, it's a year old. It's after I graduated. So it just talks about what they do. And then the sound is really good. I'm just gonna fast forward this a little bit. It was kind of an adventure to go. It was nice. That's a beautiful thing about civil engineering. You get to work outside, and I love that. Another talk. Let me fast forward. And we have fun too. We play with kids, and it was an experience for us because it's very different than the US. Their living conditions are very different. So it was an adventure. It was fun. That's survey team. Yeah, so basically we have those videos so it appeals to the general public, because those will be the people revising our reports and giving us the grants. We usually apply to, one of the grants we used to apply was to the Environmental Protection Agency, and when I was a freshman there, I started working with them, and that year we got a $75,000 grant to build a system, so that was nice. So yeah, that's it for EWB. Let me go to back to this page. Alright, so then after EWB, they put me in charge of the economics part of it, basically. We had a project that will help the community do something economics wise in order for them to keep the system going on. And we took an econ survey. This goes a little off engineering, but the final thing was that we had them plant coffee plants to sell it at a bigger scale. And I was project manager for that team, and that's how my interest for project manager came. So besides managing the econ project, at the end, so I'll feel like an engineer. I designed a community center for them, and they actually built it. So I did some drawings on AutoCAD and Visio, and I used SketchUp. Why? Because I like pretty things, and I want them to visualize what it will be like to have this community center. So they will build it, right? So I taught myself how to use SketchUp, and this is just a mock-up, not the final product, but that's what I did. And okay.
this is the program you'll all be using to do mechanical designs here.
It basically consisted on this, like, it's almost like a trapezoid building. The middle part of it was it's a living room. Because the culture there, you go there to just get in touch with them. The culture there is that it's a community. Everybody knows each other. So they'll have this place where they could meet and do their activities, right? So that was the common living room area, or this meeting room. One side was a kitchen, and the other side was a little, like a nursing room. For them to go to get medical attention, they'll have to walk on the hills for 5 hours. So there's different NGOs that come to these villages, and they'll like once a month bring a nurse and just like take care of all the sick people that are there. So that's what the room was for. They don't have sewer systems, so they have to have a little train outside, things like that. When I started to find out how to build this building, I just wanted to make a square, which is like a regular building. But I was working, like that's when engineering goes with, it interacts with other fields. I was working with an econ professor, and he was very analytical and psychological about everything. And he was like, no, make it a trapezoid so it feels like it welcomes people and it hugs people. You know, you deal with different people, but for an engineer, that means that you have to deal with angles here, angles there, how to build this, how to build the roof. You have to think about that. And that's the interactions that we have with architects, engineers, and construction people. Because we have a little joke that architects, they build this, they design this like ball in the sky that it just stands by itself. An engineer has to actually make sure that that stays up there. And a construction manager has to make sure that it's actually going to be built safely and it's possible to actually put something like that there. So that's one example of it. We had issues with the roof at the beginning, and we talked with an architect at the school, which eventually led us to find a solution to it. And a year later, after I graduated, I was shocked that they are actually building it, and I was very excited. There's a few pictures of that here. Now, in order for you drawings to go into ground and to be built, it takes a long time. First of all, you need to have you need to take the fundamentals of engineering exam. You need to have 5 years of engineering experience under a professional engineer. That's the title that you give to a person that's certified. That person basically has a stamp. I draw this and I'm responsible for this design, and you stamp it. So you work under that supervision, then you get your PE as a professional engineering license, right? So for any building in the US, you need to have that, but in Latin America, you don't. So they built it, and that was kind of amazing. So that's the insides of it was still under construction. That's how it looks from the top. Yeah, that's one of the rooms. That's the outside of it. And that's a friend of mine. He was doing some research for Cornell at the time. He was in Honduras. Those are the people from the community. They have a president and a vice president, and you meet with them to coordinate the project because they will be building it. So I call them like almost every single day and insist on them on how is the project going, and that's what I end up doing on my real job. So just nagging people a lot. Alright, so now for last, I worked at Talisman Contracting. After that, I worked at a school as a math assistant teacher. Then I worked at Talisman. I was the assistant project manager. It's a small construction firm in New York. We built 3 apartment buildings and 1 school. So that's one of the buildings. they were for low-income housing, so we worked with the government. Beautiful inside for to be a low-income housing. They were gonna have dishwashers. I was like, oh, it's gonna be better than my apartment. That's the backyard. You have to put those nets first. We had an issue with underground contamination because that site used to be a factory before, so we had to take some precautions and deal with the underground, cover it up and ventilate it in order for the people not to be intoxicated. So that was something to have in mind. That's another. They all look kind of almost the same because they were for the same client. We were for a real estate client. I think. Okay. That was it for the buildings, and I'm just gonna show you a little bit of the school. The school was in Brooklyn. It was this. It used to be a theater on the 1920s, and we basically took everything from inside, threw it away, kept that outside because it was historic, and then we built this school underneath. That was very challenging. It's actually challenging. It's harder than making it from scratch because you had to keep the outsides, and you had to take all the beams that we used to have inside, pull it out, and then put in new ones. So it was a big project. That took about 2 years. Just gonna show you some pictures and then a little bit of the how the blueprints will look. That's the finished product of the school, and it goes a lot of thought into these things. Right now, when I walk into a building, I'm kind of a construction geek. I kind of look at the ceiling tiles, the floor, the walls, what is it made of. So all these reglets, this part here, it's carefully picked by the architects, and we put it there. And they used to have putting a lot of thoughts on what they are gonna do. So we have to wait for a long time for them to pick the color of the walls, the floor, the reglets. It's a charter school, so they have to make it nice. That's the entrance. That's the one side was still under construction. The other side. It was huge. And the first floor was gonna be a commercial center, and then the rest of the floors is the school. Yes, it's basically the other side. Alright. So that was it. And just a little bit of the blueprints. Maybe. Okay, this is just a sample of the drawings. You have more than, I wouldn't even put a number, more than 200 drawings, huge, and in all sizes and in the computer. Basically, the number that I will identify them, that's the architecture firm that designed the building. We were working with two of them. One of them was designing basically the like this part, the outside, the structural part. And we have another architectural firm just for the interior designs, just for the colors, the details, what type of door we're gonna have, what type of faucet we're gonna have, what type of reglets we're gonna have, like what type of floor bases we're gonna have. That was deal with another company. But this is the bigger one that we dealt with. Each drawing is identified right here. This is A, that means for architecture, 301. Basically, you have different letters coming. A for architecture drawings, S for structural, E for electrical, M for mechanical, the drawings, for example, you had to coordinate. Okay, so this room measures the same thing on the electrical room and on the mechanical room, things like that. And sometimes that didn't happen, so you had to pay really, that's one of the key things of engineering, you have to pay close attention to detail. Because if you give the electrical subcontractor, by the way, we work with subcontract, I don't know if I'm going to explain myself well, but our company is a general contractor. We basically are in charge of building the project, and we subcontracted our work. So we pay different companies to do the plumbing, the electrical, carpentry, fire alarms, things like that. And we make sure that the project gets built on time and on budget, and that the owner is happy, our client. Yeah. And on the site, I was assistant project manager. It's a small firm, so I worked in the office and I was on the site wearing my boots, jeans, my hard hat, not like this at all. So yeah. And what I was saying is that when you give a drawing to a subcontractor, you give the electrical drawing. And if he sees that the room is a certain measurement, he will just do according to it. But then in the other drawing, it will be a different measurement. So that's a common, I would always say common issue, but that sometimes happens. So you have to pay attention to that. And when that happens, you call the architect or the engineer that they draw this and ask them about it. So that's a little example for that. And I'm just gonna pull up a couple more. So this 301, 302, 303, that goes by the size. The 3, basically, each number has a meaning. Number 3 was basically the exterior elevation size. Number 4 will be the floor plans. Number 5 will be something else. And then 1, 2, 3, this is the sites from different streets. When you have the floor plans, that was the 400s. You have 401, 402, 403, that was the first, second, third floor. The last pages was the details. For example, let me open up another one. For example, you want to look what this part looks like on looking at from this view. That's another thing about civil engineering. You need to visualize things from different angles, and that's the first thing they're going to teach you on engineering school. When they teach you AutoCAD, they'll give you a little piece of wood shape to draw, and you have to draw it from the iceberg, left side, right side, corner, bottom, and AutoCAD. You need to be able to visualize that in your head. So basically, you want to know what this side looks like, you go to this page here. That's basically what that means. And then you have these other smaller drawings that were for specific things. And you give this to the subcontractors will give this to you. This was the drawing from our steel contractor. They were building the staircase handrails. So you have that as well. And you had to, as a project manager in construction, you need to coordinate the activities of the work site. For example, you'll need an electrician to finish his work first in order for the carpenter to come in. And each person has their own schedule. They all wanna just do their project, do their part as fast as they can and leave and get paid. So you need to make sure that they come on time, they do it on time, the other person comes afterwards, and it works fine. So sometimes even the subcontractors need to talk to each other. And that's all, unless you have any questions. I'll be happy to answer them.
How long did it take to make the blueprint?
I'm sorry?
How long did it take to make the blueprint?
I have no idea. The architect made the blueprint. It's a whole process. To be an architect, it's a whole process. In order for a building to start actually building, people worked on it at least 2 years ahead. because they talk about this big idea and then they survey the site for anything that might be a cause of trouble. You talk to the bank, or you talk to people that are gonna give you the money for it, and then you have this design. Like that design that they did for at the beginning are totally different than the ones they have at the end. Because then the owner will be very involved in the process, and he'll be like, no, I want this to be like that, and then they go and change it. So once they have their final design, then they'll hire us to construct it. And even then, they'll keep on changing. So that's why you keep on talking to them. So it takes a long time for the drawings to, like, it's not like you have the drawings and then we build it and that's it. The drawings constantly changing. And you go by date. Okay, this is the latest drawing. Oh, now they decided to put the hallway that to be a smaller size or something like that. And that'll change everything else. So it's like that. It's a process.
Sorry, what school did you go to?
I went to Lafayette College in Easton, Pennsylvania.
Is civil engineering about helping the economy?
You could look it up. You could look at it that way, I think. Well, it helps the economy and the economy helps us in a way. Because for the construction industry, when the economy was down, construction building was down. Because people don't have enough money to build. For example, what this real estate firm did was that, okay, when the economy is down, we're gonna make rentals. People rent more rooms instead of buying them. So this one was for rent. So you have different ways to deal with it. And if you work in a non-profit section, then you will help people, like Engineers Without Borders. Infrastructure is an important part of a community. Having water, electricity is an important part. So if you're doing that, you're definitely helping their economy.
Anyone else?